sharing the slides and links afterwards.
Okay, awesome. Folks can see my screen? Yes. Okay, thank you so much, Kathy, for the introduction. I'm really excited to speak with you all here today. As Kathy said, I'm Judah. I'm an Associate Director of Data Science Research Methods here at Urban, where I've been for the last 3.5 years. AI has become a big part of my work, and we've used these tools ourselves to be able to unlock new research questions or do things at scale that wouldn't have been possible before. But also, we've done research to sort of investigate how these tools are gaining use in industries like housing and healthcare. I was also a graduate student in data science, kind of right as AI tools were on the cusp of this most recent explosion, and so have been kind of tracking their usage over the past few years. And so I'm excited to provide what I hope is both a practical and a pretty accessible and non-technical introduction to AI. Definitely raise your hand if you have questions along the way, or put it in the chat. And if I miss it, Kathy can flag that for me, and we'll also leave time for plenty of questions at the end. So just a couple of things that I'm hoping we can do together today. The first is most important. I want to demystify what AI is to folks who might think that it is a nebulous or overdefined or misapplied term, which I certainly do. I think the way to do that is to provide some really intuitive definitions that you can hopefully use as a reference. And I'm hoping that sets us all up to better engage with AI use cases and examples that we might increasingly come across in our day-to-day. And as the title implied, this is more of a one-on-one session. I'm hoping this can really serve as a foundation or springboard to future sessions on more specific topics that we'll probably tease but not fully dive into today. So I want to start not with AI, but taking one step further back and talking about automated systems more broadly, and I hope you'll see why in a second. So we'll define an automated system first as really any system or process that uses computation to do things like make decisions, collect data, inform policy, or otherwise interact directly with people. This ranges in complexity. This is everything from automatic payment systems to motion sensor lights to risk prediction. That would all kind of fall under this broader umbrella. And notably, all of those examples really come before this latest kind of AI explosion that began a couple of years ago in 2022. So a lot of these tools, these automated systems, have been around for decades out in the world, interacting directly with people. And we can kind of think of algorithms as the foundational building blocks of automated systems. So an algorithm is just a set of steps or even just a recipe that a computer follows. It could be as simple as take A and divide it by B, or it could be much more complex where an algorithmic system can kind of take in information and start to learn and adjust its behavior. And that's when we start to move towards these more complex AI systems. I also know NNIP had a virtual session on algorithms in the community a few years ago, and so we will make sure to add that to the resources that we send around afterwards. But I think the main point I want to drive home by starting with automated systems is that all AI falls under this broader umbrella of automated systems, and that the complexity of the system is not necessarily the thing to focus on, but rather, what is the context in which it's being used? What are the inputs and the outputs? Certainly complexity is important, and I'm not going to argue that AI isn't a major step change from some of these other tools, but I think it's helpful to start here just because there's a lot of tools that may function in similar ways to AI systems and have been around for a long time that are no less important to think about. So now we'll talk about AI directly, and I'll first note that AI, there is no one simple definition. That's probably why we're here. I think that should illustrate the breadth of this term and kind of why it gets so over or misapplied. AI is super interdisciplinary. There, it intersects with disciplines like computer science and math and stats, but also philosophy and neuroscience and linguistics and more. And so I'm going to try to offer just two practical definitions based on what AI does and how AI does it. So just kind of starting with the things that it's capable of, and granted this is a list that is evolving as the tools get more powerful, but these are automated systems, a type of automated system that can perform tasks that normally require human skills most generally. So this could be things like reasoning, learning, synthesis, decision-making, taking autonomous action, or understanding human language. And kind of the how behind how AI can do these things is all AI systems are trained on huge amounts of data and knowledge and information, a mixture of text and images and audio and all sorts of other data structures, and they use that to learn patterns to do things like the tasks above, making predictions, generating new content, etc. Maybe an obvious example, but if you take an AI model that has been trained on a Harry Potter fan Reddit forum, it's probably going to be better at predicting the next word in the phrase "Beware of Lord Blank" than a model that hasn't. So really, this is just to say that the training and learning process is really key to how AI is able to acquire all these human-seeming capabilities. There's also other more ranging into the philosophical definitions of AI that we will stay away from today, just because I think they are a little more subjective and based on things like how we define intelligence and humanness and other things like that. And not that that isn't important or relevant, but just, I want to try to ground us a little bit more in like what's practical and intuitive and a little bit easier to digest. So that's kind of the flavor that this will take today, but just acknowledging that. So I next want to kind of break AI down a little further into some of the relevant components or fields that you might have heard of, maybe not, but I think all of them are worth walking through. And it also aligns with sort of the chronology of AI, which actually started a long time ago. I think the first time that artificial intelligence appeared as a term was back in the 50s when computers were first invented. And it's since kind of chronologically expanded into these other distinct areas: machine learning, deep learning, and Gen AI most recently that we will walk through. And again, all of these fall under the broader umbrella of automated systems. And maybe as sort of a guiding example that I'd love us to keep in mind as we walk through these, just so it's a little more concrete, let's take an example that we'll try to kind of tie each of these ideas to. Let's pretend that we are a local government and we're developing a system to automate building permit applications. This is a very specific use case that in conversations with local governments, we've heard a lot about as, oh, it would be really great if AI could kind of take this very manual, tedious, laborious process and make it faster. And so I'm not saying it can or can't, but just that's an example we've heard a lot. So we'll kind of ground the next few slides in this example. So before we do that, I actually want to start with a thought experiment, which is just if we were to come up with an automated building permitting system, so not relying only on human review, I'm curious what folks here think are some of the most simple steps, algorithms, or not a perfect system, but just kind of the biggest heuristics or overarching rules that a local government could use for accepting or rejecting permits. So I'll maybe take a second. I can give folks like 30 seconds or so to put things in the chat, or if you want to raise your hand. I'm already seeing one example, which I think is right on. So like maybe if an application isn't complete, that would be an automatic reject. Zoning rules, that's another one. So like maybe if the permit is for a single family home in a residential neighborhood, that would be an automatic accept because it's in the right zoning district. Same thing with like address or location. Those are all great examples. Zip code, same thing here. See if folks have any other thoughts.
I know there's lots of housing experts in the room.
This is not meant to be exhaustive or perfect, just a thought experiment.
I guess the building type.
Yep, definitely. Cool. At the risk of, yeah, I mean, Lori, I think that's where I think this conversation is headed. We'll talk a little bit more about that, but yeah, I mean, I think just at its most basic, you can think of some of these rules that folks have put in the chat as like technically algorithms, right? They're like steps or recipes that you could automate instead of having somebody read through all the permits. I'm not saying that would go well. In fact, I think to rely only on those things would not be a good system, but you can think of like the most basic version of what we'll then talk about on the later slides as just like you have this preset, the prefixed set of rules that you're going to follow for making an automated decision. Okay, so I'm going to move us on to the first of these kind of subfields, machine learning. I'll also note that I think in the survey, like 3/4 of all the partners said that machine learning was a topic of interest. So potentially it's something we'll dive deeper into in a later session. But just to define machine learning, this is again a subfield of AI where computers are trained to learn patterns from data and improve their performance at a task over time without being explicitly programmed. So as opposed to what we just talked about on the last slide, where we would be explicitly programming something to make decisions based on the rule. Yeah, exactly, Neil. It's going to be like looking for specific indicators from the data and using that to learn those patterns over time to make decisions. So actually, sorry, I didn't mean to go ahead. So to connect this back to our example, let's say we have hundreds of historical permit applications, and we have data on whether or not they were approved or rejected. And we also have other information about those permits, things like how big the property was that was proposed, what zoning district it was supposed to be in, the geography, the price, more niche zoning, things like setback and floor to area ratio, and all these other factors. And we could train a model to learn which of those indicators is most indicative of successful or unsuccessful applications. And again, I'm not saying that would be a great system or endorsing that. I'm just saying that that is one example of how one could apply machine learning to a question like permitting applications. There's also more examples of types of machine learning in the appendix, which we'll send out after, but other examples of machine learning, if you've ever heard the terms supervised learning, unsupervised learning, or reinforcement learning, just the main difference between them is just the type of information that the model has available to it, and therefore kind of how it learns those patterns over time. And again, more information in a future session potentially on this. Okay, so, and I should say machine learning kind of, the advent began in around the 80s. There was sort of this lull in the 90s and early 2000s where less innovation, it was kind of considered this dormant field. And then with some of the more powerful computing power that eventually became technologically feasible in the 2010s, that's when deep learning sort of burst onto the scene. And deep learning is just a branch of machine learning. You can really just think of deep learning as like more powerful machine learning if you had to just, a very casual definition. Where in this case, the algorithm is set up to be what's known as a neural network. All that means is it just takes inspiration from how the human brain is set up. I think that's pretty loose depending on the neuroscientist you might talk to, but just it has many interconnected nodes and layers in the model, just the same way that the human brain is set up. It's the same exact application as our previous slide. So the inputs are the same, the outputs are the same. You can really just think the model would be more complex and more accurate, but it's going to require a lot more computing power. You could probably run a machine learning model on your laptop, whereas most deep learning models, you need like a server room or cloud computing or more powerful models or computing power to be able to run. So again, that is probably of the last 15 years or so, that's kind of the branch of AI that burst onto the scene. And then finally, to go even more specific, again, this is really the category that is getting all the attention over the last 3 years. This is generative AI or Gen AI. The definition is really in the name, but this is a category of deep learning models, of AI systems that generates new content in the form of, most famously text, but there's also image and audio and video generators. So it's doing more than just recognizing patterns or analyzing data that already exists. It's more flexibly able to do a wider range of tasks. Again, to connect back to our example, maybe instead of just training a model to narrowly say yes or no for an application, it can actually, respond plausibly to questions you might ask it about the application, or it could even take a first draft out of a permitting application if you give it enough information. Again, not a thing I would rely on without any vetting or out of the box, things like that. But if folks here have used any AI tools like ChatGPT, you can imagine that, it's capable of, like, for instance, editing a permit application or something like that. And that represents definitely a paradigm shift over the last 3 or 4 years. Most of the innovation, as I mentioned today, is happening in Gen AI, and so we're going to kind of take a deeper dive into this area. But I wanted to sort of like situate this in the broader field of AI and chronologically, because this is, when we think of this, the recent hype cycle around AI, like we're very specifically talking about Gen AI really since about 2022. So again, we're going to go through some specific Gen AI terms that maybe you've heard of, maybe you haven't, but I think are relevant and worth knowing if you come across them in the wild. The first is a foundation model. So a foundation model is a large model built through deep learning. So again, as we just talked about, this is inspired loosely by the setup of the human brain. And it really serves as the basis for most Gen AI applications that you might use. You can think of this as like a jack of all, master of none sort of model. It's trained on a huge amount of very broad data, and it's meant to be applied to lots of other tasks. And then a large language model, or an LLM, is a specific type of foundation model that is specifically used for text and language. So if you've ever interacted with an AI chatbot, you are interacting directly with an LLM, like ChatGPT, et cetera, that can simulate human conversation. So these sort of serve as the base models that are, again, it's in the name, they're the foundation of a lot of the AI that we're seeing today. Now, a couple of terms that kind of deal with how these models are updated or refined or improved that I think are worth knowing about. The first is fine-tuning. So fine-tuning refers to how these foundation models get iteratively retrained or updated so that they can be better at a specific task. So one example of this, and this is increasingly seen in lots of different fields, you might take a foundation model like Google's Gemini, and then Google has retrained that model on medical text to be better specifically at answering questions in the medicine domain. Another type of fine-tuning would be if you want the model to avoid foul language or add specific guardrails around it, any sort of kind of retraining that a company is doing. In one case, the specific task might be domain knowledge, in another, it might be content moderation. But these all refer to things that happen at the time that a model is created and trained. On the other hand, retrieval augmented generation, or RAG, is what happens when a foundation model is able to search for information that is completely outside of the training data. And it's really useful specifically for providing real-time or more domain-specific answers. So the example here would be, let's say I'm drafting a permit application, and I want to know what the max building height is in my town or in the zoning district in my town. So I can have the LLM access my local zoning code, and that can enable it to provide a more accurate answer than it could if it was just going based on its broader training data alone. So RAGs are useful for both real-time information that might have taken place after the time that a model was created or trained, and also if there's very specific information that you want a model to retrieve for you outside of the huge body of text that it's trained on. So these are two different ways that models are refined and improved upon to be used today for a whole host of different tasks. And then the last set of terms I want to walk through have to do with the open or closedness of a model. Right off the bat, I will say, if anyone has heard of an AI model that's claimed to be open source, I would be very wary of those claims. Some of them do exist, but most of the time, and I guess first I'll define what an open source AI system is. This is a system where everything is available. So the training code used to create the model, very importantly, the training data. So this is often billions and billions of gigabytes and documents and stuff that a model is trained on. The architecture of how the model is set up, the methodology, all of this is publicly available so that you as the user know as much as the developer did who created the model. Most of the time, if you hear someone say that a model is open source, what they really mean is that it is open weight. So an open weight model is one in which the weights of the model are released so that the system can be freely used by and altered and tuned by other people. But most of the time, this one step deeper set of information around how was the model trained and more specific methodological questions are not made available. The last type of model is a closed weight system, and this is the least free. This is the weights are proprietary. You generally have to pay for access or are restricted in some way. And you as the user have zero control over how the model was trained or its performance. Yeah, great question on model weights. It is a technical term, so it's a little unintuitive, but the model weights are essentially the result of the training process. So if you have the model weights, you could download an entire model onto your local computer, and then from there you'd be free to, first of all, you'd be able to freely use the models, you don't have to pay for it. And second of all, you'd be able to fine tune it, as we talked about on the previous slide, and alter it generally in ways that you can't do with something like ChatGPT, where maybe you can connect to the ChatGPT model if you want to build your own product, but you're not able to fundamentally change the ways in which OpenAI is deciding to build and train that model. The less information, the reason I'm making this distinction is because, of course, we can think the less information we have about a model, the harder it is as the user to audit its outputs, to evaluate it, the less control we have over it to get it to do what we want. And of course, if anyone has interacted with AI, it's already hard to know why and how it's doing what it wants. I will say the other side of that coin is that some do worry that the more powerful the open weight model is that is released, the greater the risk of a bad actor who has access to that model. So there's concerns that people who could get access to sufficiently powerful open weight models might be able to do things like sow misinformation or, very dystopian, but build biological weapons. There's been all sorts of things that maybe folks here have seen in the news. So I'm not saying that one of these is better than the others. I think the two main points I want to make are to be wary of someone who says something is open source, and to just kind of understand the different options along this open closed spectrum, understanding that the right option is going to depend on the use case. Okay, I now want to give a very high level overview of some of the major AI players to know about. Disclaimer, this is a huge simplification and AI companies are notoriously terrible at naming their models. So I don't have all the different model names like Claude, V4, Opus, and Sonnet V1, and GPT-o1, and all these different things. It's generalization, but I'm hoping this gives a decent idea of some of the major companies that I think are useful to know about. I'll start with OpenAI, which has their ChatGPT model, which most of us have heard of. Any model that starts with GPT is typically an OpenAI model. They are really credited with popularizing large language models as this consumer tool in late 2022, and I think that's one of the biggest reasons for this explosion that we've seen since then. They also partner with Microsoft, so you'll see a lot of their products integrated, and they get access to Microsoft's computing power in exchange for Microsoft getting access to their model, and it's a kind of a partnership that exists right now. Another major leader in AI is Google. Their Gemini model is considered at the top of most of the leaderboards to the extent that we believe them. The leaderboard's not Google. And I'll also say they're one of the few companies that have thus far proven AI to be useful in areas outside of consumer tools. So their AlphaFold's protein folding AI application won a Nobel Prize last year. So they're one of the companies who has found a use case for some of the promise that I think we've heard about, talked about by AI evangelists so far. Another major leader, probably anecdotally speaking, like the big three, I think Anthropic is another major US AI company. Their model is called Claude. They were founded by ex-OpenAI researchers who were concerned about safety and transparency. So you'll often hear more discourse about that from Anthropic employees than maybe in other companies. That's a good flag, Neil. There are absolutely players from this who are missing, so I'll maybe mention Mistral in a sec. But Meta is probably one of the most kind of leading open weight model providers. So their Llama model is one of those examples of a model that anyone can access and download for free. Mistral is another one that I think is also open weight. That might be wrong, but another one of these slightly smaller companies, but is definitely one of the bigger players in AI. xAI has developed the Grok model. So this is Elon Musk's company, and it's integrated into X. I also mentioned this just because, given his financial resources, this is one that has been catching up very quickly lately. So it's possible this could be a bigger player in a year or two. So worth knowing about. And the last one I'll mention is DeepSeek, which is an open weight model in China that got a lot of attention because it performs comparably to a lot of the leading American models that are at the top of this list, but with way fewer resources. And so there was this thought that this was sort of China's entrance into the AI competition field, so it gained a lot of geopolitical attention. A lot of these models are also embedded in sites and apps that you might have interacted with that aren't immediately apparent to you. So what you should take away from this slide is these are a lot of the biggest, again, foundation models. So these are good at general purpose tasks. They're trained on lots of data. They're not specializing in anything particular. And they often get repurposed for other products and things like that. And as Neil pointed out, this is very non-exhaustive. There are other companies not on here who might have products that are not foundation models, but are still important. So if you ever heard of Perplexity, the AI search engine, or Elicit, the AI literature review tool, these are some of the other names, but this is just a very quick overview. Okay, I want to talk a little bit about how we can distinguish among all of these different tools today. Maybe some of the questions that I myself have asked when I'm trying to choose a model for the task I want to do, and I'll try to connect each of these back to this permitting example as well. I'll also say that some of these capabilities, even at the time that I drafted these slides, have probably become a little less or a little more ubiquitous than they were at the time that I drafted them. So just to get a sense of how quickly things move. But the first thing I'll mention is whether or not a model is able to search the web for current information. So we talked about that previously, like supplementing the training data with data that it retrieves from the internet. So like if I ask the model to find an update to the zoning code for my town, could it go and grab that information from the web? Can the model work with uploaded documents, images, other flexible files, and how large is we call that its context window, so how much information in a question or a prompt can it take in from the user? So could I take a 600-page zoning code and could I upload that whole PDF to the chat bot, or would I have to break it down into smaller files? One that's maybe less useful here, I don't know, but important certainly for data science work is, can the model both suggest and actually execute code? So like, can it draft some code, test it, debug it if there are errors in it, and then test it on a toy example and make sure it works? I think this is a pretty important one, and definitely we've seen a lot of the biggest efficiencies so far in areas like software development and programming. Another one that the AI companies refer to as reasoning. So can the model think step by step, and can it give you intermediate work as it gives you the final response? So like in our example, if I ask the model to accept or reject a permit, could it not only do that, but actually walk me through all the sequential steps that it took towards making that decision in text and show me all the information and the sources that it considered to do that? And then the last bullet I think is worth pausing on for a second, because I think this is probably where a lot of the discourse is in 2025. So a lot of the big AI companies have what's called deep research. ChatGPT has one, for example, where you can ask it to do something like, give me a first pass of a literature review of building and permitting reforms in the US. It might ask you a follow-up, and then it will go off for like 5 minutes. It will search the web on its own, find lots of sources, summarize them, and compile them into like a first pass of a report that is often pretty good. So it really combines a lot of these capabilities together. And this is what's called agentic AI, or agent-based models, where the distinction is that a basic chatbot might just give you information that then you yourself have to act on, whereas an agentic model is one that can kind of autonomously go off and make decisions and maybe operate for like several minutes on its own before it kind of gets back to you. Another example of this that is not possible now, but people talk about a lot, is like, could I have AI book my flight for me if I wanted to go somewhere? That's probably where we're heading eventually. But right now, at least, these deep research capabilities are probably the most prominent example of agentic AI. That and the sort of code executors is another good example. So that's just a flavor of some of the different things that AI models can do. And of course, like, the more complex the capabilities, the more it will cost you as a user to use them. And then just, this is an image from a great Substack from Ethan Mollick, written in February, so actually very much already out of date, but these are a few different models and a bunch of different dimensions, and he sort of grades them on different aspects. So definitely a good reference, one that I go back to from time to time. And so, yeah, I haven't seen a lot of other comprehensive reviews like this. Lori, that's a longer question, so I'm gonna hold off on that. Just
Yeah, if we can get to the slides to make sure we have time for questions.
yes.
Lori, we'll come back to you.
Yeah. Okay. I have one slide on the limits of AI that is not an indication of what I actually think about the limits of AI. It is the tip of the spear, and this should absolutely be the topic of a full other session, but I just wanted to give a little intro to it here. Two major categories of risk that are worth mentioning. The first is hallucination, which I think is very vivid, great choice of term, whoever came up with that. But it's the idea of AI kind of creating fictitious or totally erroneous or information that it can't substantiate. So we've all heard examples of AI making up citations that don't exist, or just making information up. It depends on the types of tasks that it's given. At a basic level, the reason this happens is because AI models are probabilistic, and so you can almost envision them predicting the next word in the sentence as how they think. And so a model with some inherent uncertainty baked in is going to be prone to not always getting things right. This is not an easily solved problem, and it's certainly, it's come up. There's been like journalists and lawyers who have cited made up stuff, or who have been caught with models that hallucinate, and there's all sorts of copyright and plagiarism issues and things like that. It's not an easily solved question. I don't know how close we are to really solving it, but I think certainly a concern for anyone using AI, and should inform what we do and don't choose to use it for. Another risk I'll talk about, and this actually might even connect back more towards some of the models we talked about at the beginning, is not for generative AI models, which we've been talking about, but for predictive models, which are used to automate decision-making. So, again, this is a whole topic unto itself, but we know AI can be opaque. We don't really know why it's making decisions. It could be trained on information that is incorrectly measured, or it's biased against certain groups. Human decision makers might rely upon it too heavily, or just flatly just like use it wrong. And it could be used to exacerbate disparities that we already see. So I think bias, equity, privacy, and even environmental risk, which we haven't even mentioned, are all worth discussing and should be a topic of a follow-up session. But I want to underscore that this is a huge concern of any automated systems more broadly, I would say, not just AI, but certainly the scale of AI makes it especially concerning. Okay. The last thing I want to do before we kind of pause for questions is offer a few, I don't know if advice is the right word, but some steps that I would myself consider, or that I have considered when I've been interacting with AI tools myself. The first thing is, I think, a useful set of dimensions, and this is not an exhaustive list, of how to evaluate AI tools. I'll also say sometimes it's really easy to tell, like if I ask it something, like a very binary question and it gets the answer wrong, it's very easy for me to tell if it got the answer right. There's also plenty of questions where it's very difficult to assess any of these dimensions. And so sometimes this needs to be done manually and using subject matter expertise. For certain dimensions, there are tools that can kind of help to automate that evaluation. I think in some cases it's very reliable. In other cases, believe it or not, there are cases where folks use AI to evaluate AI, which is just very inception-y and I don't love, but some dimensions to consider: accuracy. So obviously, is it getting the answer to your question correct? I think hand in hand with that is completeness. So is it leaving out important context or details that might sort of color your impression of its answer? Relevance. So is it giving you an up-to-date answer, which, I think particularly before models could search the web, there was, a hard cutoff date after which it would get questions that happened after a certain date wrong because it didn't know the answers. I think that's a little less of a concern now that the models can kind of go retrieve external information. Attribution. So of course, are the sources, do they exist? Are they reliable? And are sources cited for the claims that are made? One thing I have explicitly done is, I have instructed models to provide sources for everything that they will claim to me. They're often linked right in their answers. Occasionally the links are broken or they go to non-existent places, but it's usually easy enough to vet whether the sources are real. It just takes a little bit of extra effort to obviously to go and check that. An underrated one I think is actually uncertainty. So, obviously questions can be subjective. There's some evidence that suggests models might be overtuned to please us or tell us what we want to hear, or even over flatter us. And so there are times where it might be more confident than it really is because it wants you to be satisfied with its answer. And so I think it's an important one that the confidence of the model is correctly calibrated with the type of question that you ask, or it can even just say, I don't know, if it's not sure. Consistency. So if you type the same exact question into an AI model 5 times in a row, the exact text it gives you will likely change every single time, again, because this is a probabilistic model. Most of the time, the substance of those answers will be the same, but I think it's worth vetting, and maybe even more than we already are, how consistent a model is if you ask the same question. Cost and time. I think time is usually easy to assess, and really for only these like way more intensive use cases is time really a concern, but cost certainly could be. Environmental footprint is not on here, but I think is tied up into cost. And then again, bias is listed last year, but is no less important. But can we tell if the answers are perpetuating stereotypes or prejudices against certain groups? There's absolutely research that suggests that it can be doing that for translation, or if it infers a certain identity of the question asker, depending on what is being asked. And again, I think this should be a topic of a whole other session, but just to say, just because you're talking to a model and not a human, I'm probably preaching to the choir, but bias can certainly be present in these tools. And then I'll also offer maybe more practical guidance, which is to say that for folks who have maybe stayed away from AI up to this point, I would say first, I completely understand that inclination, and I think it is like impossible not to be overwhelmed by sorting through what's real and what's not real and actual uses of AI. I would strongly encourage everybody to experiment with tools themselves, but maybe what I would say is to first try out AI in domains that you yourself know a lot about. So where you're able to really see like, hey, I am an expert baker. Is AI giving me correct advice if I'm asking it questions about baking? Really prioritizing the low risk settings where if it's giving you answers that are wrong, it's not harmful. I would say there are very real questions to grapple with around if and how and when we should be embedding AI into systems that interact with people, but just at a purely individual level, my strong, this is editorialization, but I think, you know, AI is definitely here to stay, and it's worth at least building some fluency in the same way that we have with any other technology that's come before. So I would say testing it for domains that you have personal expertise with, low risk settings, and then asking it a mixture of questions, being creative, some that have very specific factual answers, other more open-ended prompts. Yeah, I think all of those tools have helped to demystify AI for me and to really help see, okay, for these very specific types of tasks, the risk is low, the utility is very high. I think, you know, to be purely a skeptic is probably putting one's head in the sand. To be purely an evangelist is naive. And so I think the truth, as always, lies somewhere in the middle. I'd be curious to open up the discussion and see if there are other areas where folks here have themselves experimented with tools and found any success. But again, my biggest suggestion would be for those who maybe have spent less time with the tools to just try them out, just to build your own understanding with them. Okay, just to close out, a couple links, which again will stay in the slides, but just some non-technical favorite sources of mine for staying up to date. Actually, the third one is more technical. The first two are very untechnical, that I think are really helpful for kind of sorting through a lot of fast-moving news and just largely staying informed and not feeling like I'm tuning out because it's boring. And yeah, I just to close out, you know, I'll review some of the things that we talked about. You know, we started with some of the very foundational terms, different types of systems, some things that I think are distinctions that are important to make. We talked a little bit about the AI landscape of tools and the companies and what the tools can do. A little bit about how to sort through the useful and the less useful, and then we tried to ground that in an example that maybe is true for some of the partners that you work with or is of interest to them. You know, as Kat said at the beginning, we are always looking to have discussions and to form partnerships. So if there's any questions that you don't get to ask in the next 15 minutes, definitely reach out to me anytime. I'm very happy to discuss more. And yeah, would love to hear any further questions folks have now. Thank you so much.
Thank you. Great answer. I think Laura answered her own. Well, she asked about what was typical about using things just on the web versus protecting. Many of our partners have confidential data, PII, and I don't know if you want to talk a little bit about how Urban's approaching that.
Totally, and I probably can't give it justice to kind of walk through the full Urban policy. Yeah. I would say our Chief Information Officer, Graham McDonald's, on LinkedIn, again, we can circulate this, has this whole blog series where he talks in depth about all the different decisions that Urban has done. I very objectively think he's done a fantastic job of kind of like involving a lot of people in the decision-making process, making smart decisions that sort of balance some of the trade-offs we talked about. So at Urban, we similarly cannot upload any what we would consider like proprietary. So that's obviously confidential data, but even just like data that maybe has proprietary value to Urban into the tools. We can use tools for editing. I think for certain types of like very low stakes drafting, our team definitely uses like code assistance tools for programming, although we need to like specify when an AI has generated code and when it's reviewed code. Microsoft Copilot is also the kind of Urban approved like general purpose AI tool that we use at Urban. I think third-party tools are approved, but for like a narrower set of uses than like all the things that we can use approved tools for.
I can share the tool list that Urban has been using. Like there's a session on elicit and lit reviews coming out for other ones. Other questions? I'm sure lots of people have lots of opinions.
Yeah, opinions are fine too. Questions, comments, concerns? On premise, Neil, or in promise?
You can come off of mute if you want to just explain your question too. It's not that big of a group.
Well, you know, this is Neil, okay? I think it's on promise, not in promise. have you used any LLMs within your environment? We are just trying. We are trying to find a solution for fine tuning. We already are dealing with some vector databases, using pgvector and things like that. We can do some cosine similarities stuff. But on the other hand, we are relying on OpenAI Chat GPT-4 Zero right now. That's not going to be a long-lasting solution for us. So is there any advice from you on how we can get something? Because we are trying to get a beef up GPU server. So hopefully, we can implement one of the language models within that. I'm thinking about Llama 3, but I'm not sure about that yet.
Yeah, I mean, the full answer is probably like a broader call, and I'm happy to touch base. I think the short answer would be, I think things that we've looked at would be like cloud computing options that give you more GPUs. So like Urban uses Amazon Web Services, which has a whole sort of environment for bringing in some of these models, some of the ones that we talked about in this presentation. Google Colab also offers some free GPUs depending on how big your needs are. I don't know exactly what they are, but yeah, maybe we can follow up to talk about that more specifically so I can try to give a more informed response.
Yeah, good.
I'll re-up my question, which is just has anyone here themselves found anything to be effective when just like exploring AI tools or like trying to figure out what they're good at, what they're not, or just kind of like wading through the mess like everybody else is? I'd be curious. Yeah.
I've used both Gemini and ChatGPT to fix long Excel formulas, especially when I'm trying to match multiple data sources across pages. It's really easy to or maybe just for me, it's easy to like lose your column position, and you can dump your broken formula in and just say like, I need this to do this, and it will just spit out a repaired formula, and it saves like a half hour from having to like go through each cell. I found that especially helpful. And then the other thing I found it like helpful for my meeting notes tend to be like a mess because I type really fast. And if you just say like, can you make some sense of these? It will, and I'll prompt it. I'll say, don't change the content, but just like make this look better, and it will do that, or it'll put it in like a memo format, or like, so it can make sense of a mess pretty quickly. But I've gotten better about saying like, don't change the content, don't use personal pronoun I, like, right, like I want it in a professional tone, like really being careful about how you're prompting.
Yeah, those are great. And just two quick comments on both of those, because I think those are great examples. The first is, I think like anything related to like technical or programming work or Excel is, in my opinion, a really great use of AI, just because it's both very good at those tasks, and also it's very easy for you to vet the output. Like if it works, it works. If it doesn't, it doesn't. You can even have it provide comments and documentation if you're not understanding why it's doing what it's doing. So I think that's a great example. And similarly, I have saved many hours of tedium by just using AI for those specific tasks. On the summarization, I'll also say it's a great flag about prompt engineering. So prompt engineering, for those not familiar, is sort of the term that we use to kind of optimize what exactly we ask the model. So it's providing it like specific instructions around, I need you to cite a source for every claim you make. I need you to not change any of the original content in this way, limit to this word count, like whatever your instructions want to be, they can be. I think that's another reason why it's great to play around with the tools, because you can understand how they might differ from your expectations and make sure they're acting basically the way that you want them to. So both great examples.
I will say I've had mixed experience, like with trying to get, now maybe because I'm using Copilot and I know it's like one of the younger, less trained systems, but I'll spend, a lot of time trying to get it to just do something for me. And then at some point I'm like, okay, this has been 20 minutes that I've lost. I could just do it myself in the next 20 minutes. So, some of that happens. Like I did find, like I was trying to get it to do something for me in Excel, like make a Gantt chart from this spreadsheet of master, dates that we have going. And it kept telling me how to make the Gantt chart, and I kept telling it, well, can you, and then it made me one, but it made it as like an image. I'm like, no, I want to make it match my style guide. Like I need to make it these colors and, I want to remove these axis lines or whatever. And I kept, and it kept telling me, yep, here it is. I put it in your spreadsheet for you and it wasn't there. And so I finally kept telling you it's not there, that's a PNG format, that's a TXT format. And finally I just said, forget it, I'm gonna make it myself. But then it sort of was very nice and still said, well, since you feel confident, here's the instructions for how to make it step by step, And so I was able to kind of follow and still do it. But I've had a lot of frustrating experiences where, I try to get it to do something, but then I'm like, it's not doing it like I would want, like I would do it. I did have a different experience. Like just yesterday, I had to put together a graduate school recommendation letter for one of my staff members who's applying to a PhD program. And I had like her personal statement, her resume, and then I had her last appraisal. Like she's like one of our top people, So all the nice things that we had written about her in her performance review. And I just sort of, and then I also told it about the program she was applying to. So with those 4 sources of information, I was like, draft me a really strong recommendation letter. Now I still had to go in and like, I don't like that paragraph, but then I was just editing rather than kind of starting from a blank page. So it's been mixed depending on what I'm trying to get it to do.
Yeah, super fair. I mean, I think there's like, in all of our fields, there's going to be certain tasks that we discover, and I've certainly had similar experiences that it feels like you're at the tip of your tongue, like it's so close and it's promising you it's right there, and then it's just not what you ask for. And I think just as we need to learn how to use AI to save time for the tedium, it's also like, how do we avoid using it for the things that actually it's just not yet that good at, which I totally empathize with.
I think there's more societal questions.
Of course, I use it for programming, every day, and it fills me, if I type a comment and, if the comment has enough instructions, Copilot will just create the code for me, that is, it never happened in the past, right? So it's amazing.
And it takes you less time to type the instructions than just to type the code yourself.
Exactly.
Because that's where I haven't hit that tipping point yet. I feel like you were talking, Judah, about like, make sure you tell it, don't use I and, or, giving it all those instructions. I'm like, I could just have written this myself by the time I tell you all the specifications.
Well, you're right, it depends, right? So for me, it is just pressing the tab button, it just goes through the list, I mean, yeah. So anyway.
Do we have, I think we're not environmental experts, but do you have any thoughts on the big picture? There's some question in the chat about the environmental impacts and pollution and impacts of data centers, and I'm sure, and all of those things.
Yeah, again, totally not an environmental expert, and I think this is a whole further discussion. What I will say is I'm actually going to drop a link in response to this, which is again, classic to drop a podcast recommendation in a presentation, but this is the Hard Fork podcast. They had on an environmental expert to talk about this exact question in the middle of this episode, and I found it really strong, and it was sort of setting the tone for like, what are the types of AI uses that are really a drop in the bucket compared to things we already do every day versus what are the ones where like, yeah, sure, if you're doing something that you're using AI for something you totally didn't need to use it for, or if you're a part of a bigger organization that themselves have a bigger AI footprint, like then the climate impacts are much bigger. So would recommend that as a listen. Thorny topic, one I absolutely don't have good answers for, but I appreciate you both flagging it because I totally agree that it's something that needs to be part of the discussion. Laura, reading your comment, I feel like there's almost two different pieces there. There's like the low-hanging fruit of using AI transcription, but then maybe also the like it's used in places where you don't expect it to be. I don't know if you want to say anything more about that, but I agree.
Although Laura, I'm gonna adopt that metaphor now, I think, the added sugar. That's a very public health metaphor. Laura comes from a public health background, so we should.
Yeah, I feel like it's just this sorcery that we take for granted. And I actually think that AI literacy, like nutrition literacy, is going to be important as a very basic first step to be able to identify when AI has even been used beyond just like looking for hands that have too many fingers. I don't know. We stayed pretty far away from it for generative stuff, but I would love to be able to use it more for the things that we've always used tech for automating tasks so that we can free up our brains to think and synthesize and that kind of thing. Sorry, I have a cat helping
And
me.
do the more time for engagement in the ideal sense and less time on the coding. Yeah, I think that's true. So yes, it becomes. We're not allowed to make it for images. That's actually the one thing that's actually definitely forbidden on our side. No images, no Gen AI images coming from the Urban Institute. So well, this has been really great. We're at the end of the time period. Thank you so much, Judah, for laying everything out so simply. I think the comments from the surveys, the questions that you have will definitely guide what we, the different pieces we do. Next, we expect to do some deep dives with probably smaller groups of people that want to go into different kinds of topics. I have also been, a lot of my conversations have been talking about sort of the state of AI in local governments and how that affects residents. So hopefully we'll be able to share more about that too. So yeah, please just give me feedback. This is an enormous topic that I feel a little overwhelmed with the amount of information coming at me every day about it and the different aspects. So hearing more about what people want to share, we could have a, I don't know, practice your prompts session. Finn can give us tips, and Neil. So yeah, hearing about what you're interested in, what you're struggling with, or where you think the promise might be, or your biggest concerns would be a great help as we navigate finding what would be most useful for us to do together or to bring in outside experts for.
Yeah.
So
Sure.
Thanks so much for everybody for hanging in there. And we will send out the links and the slides and recordings for others, for if you have colleagues that missed it or you want to review. I know I want to review all those references and start digging into those podcasts on the way to work. So have a great day, and we will see everyone later.
Thanks, y'all.
Thank you.